Excuse me, I'm looking for Jay Johnson.
Right over there.
Thanks.
And take a look at these.
All right, but we better hurry.
Why?
Well, I'm not sure, but I think I'm being followed.
Who?
I'll tell you later. Wait a minute. You're not going to show me in here, are you?
No, it's too dirty. In my secret room. Come on. My secret room. Sir Wembley, take these. What I'm about to show you is a little like carpentry. Oh, and be ready for some surprises. See what I mean?
You and Diggins must have the same interior designer.
Same designers, different color scheme.
Oh, by the way, here's the board.
What did you do, bury this thing under a pile of rocks?
Almost.
Well, let's get started. Your excavating job looks quite good. So, next I should show you how to repair an internal conductor. Now, this spot right here, let's assume it's been damaged, and I'll scratch it to mark it. Now, what we're going to do is cut that part out and then put in a piece of replacement foil. Well, that'll teach you about butt joints with bevel cuts.
Butt joints with bevel cuts?
Nothing to it. It's simple carpentry. Here, I'll show you on this wood that you brought in. We're down on the 3rd level. Here's the length of the run, and we'll mark the damage right here. We're going to cut out this section, then take another piece, cut it exactly the same length, and solder it in. Now, we could just stack the new piece on top and use a couple of lap joints to hold it. But there's a problem on the next level up. Well, there may be a run going right over the top, and by stacking it, well, we've changed the dielectric distance between the layers and added excess metal on the ends. This could mess up the circuit impedance. So, we need to make an exact fit, and we can do it with straight cut butt joints like this, or better still, with bevel cuts. The problem with the straight cuts is that when you solder it in place, everything's fine when you do the first end, but then you come over to the other one, put your iron down here, it sends heat back to this joint, melts it, and it pops up on you. Also, the bevel cut gives you greater solder joint surface area. The trick is to use these bevel cuts, angle the blade so when you cut out the damaged piece, you leave an undercut on this conductor end and an overcut on this one. Then you take your replacement piece and bevel cut its ends so they lock in with the overcut on this end and the undercut here. Now, when we put them together and go to solder this end, this is locked under there and can't spring up.
How long does it take?
Oh, not long. You'll be in charge of mixing the epoxy. So, here we go. Using a number 11 scalpel blade, we'll make our bevel cuts. Take your time here, and don't rush it. You're only going to have one chance to do it right. You have to be very careful here. The object is to cut just through the copper, not into the substrate underneath. It's very easy to go on through, and if you do, then you've got yourself a whole lot more work to do. Now we apply heat with the lap flow tool to weaken the epoxy bond. At the same time, we use the side of the scalpel to pry the conductor loose. Use the tweezers to pick up the free conductor. There we go. Now for the replacement piece. We need one that's the exact thickness of this one. A thicker one could decrease the laminate thickness. It looks like it's 1/2 ounce, but let's check it with a micrometer to be sure. Yep, it's 7/10,000ths of an inch thick. That's 1/2 ounce. And I think we've got some right here.
Right where?
Right here, from this frame of commercially available straight conductor replacements. In many cases, we can match the internal conductors with these.
Right. I knew that.
Okay, we'd better use this. It's a little wide, but we'll trim it up later. Now, one of our matching bevel cuts on this end. There. For this other end, it doesn't matter. We'll purposely cut it too long because we have to fit it exactly. I'll place it in the excavated area to measure for correct length. Oops, come back here. Overcut to undercut. Snug it up a little more. There. It's just a little bit too long, so right here is where we'll need to trim. Better take it off the board to do it, though. This end will get an undercut since it has to match with the overcut on the conductor end. Now, add flux and pre-tin the conductor ends on the board, making sure solder covers both beveled edges. A little cleaning now, and all will be ready. Since we'll be reflow soldering, we'll need to wet the surface of the work with flux. But not much, less than 1/10 of a drop. The reason we need it is because we won't be getting it from any additional solder. Now, you little devil, in you go. Wembley, there's a box of toothpicks on my left somewhere. Hand me one. A very light touch is all we need here. No pressure with the iron. We could drive the run straight down to the next level. Beautiful. Now we must clean off the flux residue. We must inspect the bevel joints to be sure we've got a good solder connection. Here we have a little too much solder, so we must remove the excess with the chisel. We don't want to decrease the thickness between laminates when we rebuild the board. Now for the width. We have to trim off the excess from right here. Okay, time to mix. Here's the epoxy made up of resin and hardener. Just mix a ratio of 2 parts resin to 1 part hardener. But we need to give it some strength. Where's my ground up circuit board? Oh, here we are. Now just a couple of pinches. Mix it all together slowly. Air bubbles are the big problem with the epoxy. The slower you mix it, the less bubbles you get. While you do this, I'll burnish the repaired conductor. A little here and this little bit there. That about does it. Oh, what's this? A bit of exposed copper showing. Well, in this case, it's all right. We're going to be encapsulating it anyhow.
Is this all right?
Uh-huh. Good timing. All ready for a touch of epoxy. Smush it into the rounded corners a bit. And now, with our trusty double-end explorer, we attack the air bubbles. The way to do this is to move them right over to the edge. Oh, lots of bubbles, plenty of troubles. If we don't get them all out, they may outgas and explode in space after the epoxy cures, and that can ruin our job. That's Charlie's plane. He must be doing the ribbon cutting act. Oh, today's lineup is supposed to be wing walking, Red Baron, and final formation. I'm never sure who's up first.
Did you say Red Baron?
Sure did.
Red Baron.
Well, not much time left, but we're about finished. We'll cure this in the oven and then chisel it nice and smooth on top so it's right at the level of the circuitry on the next layer. Then we just repeat the whole process, putting in new track and rebuilding the layer.
So that's it?
Well, there is another way to do this that you ought to know about. Instead of a piece of copper foil, you can use this conductive epoxy. It's loaded with silver, and you can make your own track with it. Imagine that we've excavated down and removed a small piece of damaged copper conductor and prepared some conductive epoxy. You put it across the gap between the conductor ends, just like it was a piece of foil. Cure it in an oven, and then trim it and shape it with a chisel. This is what it should look like after you've shaped it. Now, just a little more burnishing to polish it up. To finish, you plate it with copper, but first set the DC voltage for 3 volts. Then put the solution right into the excavated area with the positive probe in the pool and the negative one on the epoxy. The copper plates out over the conductive epoxy. Plating time is about 3 minutes. Other conductive epoxies which can be used are copper-filled epoxy and gold-filled epoxy. Then you clean, and clean it to remove every trace of the chemicals. Neat, huh? It's not as strong as foil, but it's a whole lot easier, and you don't have to apply any heat to the board. Whoa, time for me to move it. This I'll take to the oven, and I guess you'll soon be going back to the Empire. Wait a minute, that isn't the Baron.
It's wormwood.
Quick, get to the plane before he comes back.
Right.
Oh, and bring the parachute.
Parachute?
Yeah, just in case.
In case what?
Come on, Wembley! Pull the chocks.
Chocks?
Wembley, the wooden thing's in front of the wheel.
Oh,
Come on. Here, wear these.
Oh.
You ready?
Yeah, oh, yeah.
You better hold on.
Don't worry.
You're gonna have to jump.
Right. What?
I'll keep him busy.
Yeah. Down there. You want?
You can do it. Now listen.
What?
See, Wembley, find the captain of the William B. Tennyson.
William B. Tennyson, right?
Yeah, he can teach you the rest.
Right.